Let's practice with the product rule for derivatives, which says that if we have a pair of functions f and g, the derivative of their product, the derivative of f times g, well, you might think it's f prime times g prime, which might be nice, but it isn't. It's a slightly more complicated formula. Still has an f prime and a g prime, but this f prime you multiply by the original function g, and this g prime you multiply by the original function f. So the derivative of f times g is f prime g plus f g prime. Let's do a quick example. So let's find the derivative of the function 7x. Now we already know it's going to come out to 7. But let's see what happens when we apply the product rule. So the product rule tells us, if we consider the first function to be 7 and the second function to be x, that this derivative will be the derivative of the first function times the second function plus the first function times the derivative of the second function. All right, so the derivative of 7 is 0. So this whole thing is 0. And the derivative of x is 1. So this is 0 plus 7 times 1, which is 7 as desired. Here's another derivative that, while it looks terrifying at first, we can use properties of logs and then the product rule to take the derivative. So let's first apply a property of logs. That logs bring down the exponent. So this is equal to the derivative of square root of x times log base 5 of x. Now this looks like something that's manageable using the product rule. We've got our first function here and our second function here. So we can take the derivative of their product. So according to the product rule, this should be the derivative of the first function times the second function plus the first function times the derivative of the second function. All right. Now, by now, probably done it a few times. The derivative of root x is 1 over 2 root x, log base 5 of x, plus, and now we have root x. Now, the derivative of log base 5 of x is almost just 1 over x, but we just have this times natural log of 5. All right, and you could simplify this in different ways, but why bother? If the problem doesn't say to simplify, just leave it like this for full points. Quite similarly, we have a formula, the quotient rule, for the derivative of a quotient of functions. So we've got a fraction with one function f on top and another function g on the bottom. The derivative of this is again a fraction. And it looks a bit like the product rule on top. We have f prime g and f g prime, but with minus in the middle instead of plus, and on the bottom there's g squared. So the bottom function and square it. Now, there's some kind of song for remembering this, but I'm not going to do it. All right, here's an example. What happens if we apply the quotient rule to 7 over x? All right, now we don't need the quotient rule to solve this because we know that 7 over x is the same as 7x to the negative 1. So we could use the power rule on this, but let's use this example to practice the quotient rule. Okay. So the quotient rule says that this derivative will be the bottom squared, so x squared. And on the top, we have the derivative of the numerator f times the bottom function minus the numerator times the derivative of the denominator. The derivative of 7 is 0 because it's a constant. So we get 0 minus 7 times 1. The derivative of x is 1. Over x squared, so that's negative 7 over x squared. All right, but let's try it with a more interesting, complicated example. All right, here's a reasonable example. We've got a polynomial on top, exponential on the bottom, that's e to the x. Let's take the derivative of this thing. First, I'm going to write down what the quotient rule tells me about the derivative. The quotient rule tells me it will be the derivative of 5x to the 8 minus pi x, it's a prime, times the denominator e to the x, minus the numerator 5x to the 8 minus pi x, times the derivative of the denominator, all over the denominator squared. So even though this looks complicated, we only have two derivatives to do. just right here and right here. All right, so derivatives of polynomials are easy, or at least routine by this point. So this derivative of this polynomial would be 40x to the 7 minus pi. And we've got times e to the x, and then we have in parentheses minus 5x to the 8 minus pi x. And then this is why I really like the number e. The derivative of e to the x is just e to the x. And then over the bottom, or over the denominator, we have e to the x squared, which you could write in different ways, but why bother? So this will give you full points if this is your solution.